All right, so we've got 3 practice questions here. I'm going to start with this first one here. And it says, I have a lube oil heat exchanger in service with the following inlet temperatures. So what I like to do is I always look for an excuse to draw a picture. So following along in your book, I've got a heat exchanger. It's a lube oil heat exchanger. And it says lube oil inlet temperature. Here's lube oil coming in is 130 degrees Fahrenheit. And it says cooling water inlet temperature is 70 degrees Fahrenheit. So the cool water is coming out here. And I know it's going to be leaving at some increased temperature, and that this lube oil is going to be leaving at some reduced temperature. All right, so this temperature here of the cooling water should be going up, and this should be going down. So assuming, and this is the key, so here's what I should write down. I know that all of the heat transferred out of the oil is transferred in to the cooling water. Right? Therefore, there's no phase change in a lube oil heat exchanger like this. So I'm going to say, well, mass flow rate of the oil times the specific heat capacity of the oil times T hot minus T cold of the oil is equal to the mass flow rate of the water times the specific heat capacity of the water times the difference in temperature of the water. Then it's very key that you read the assumptions. Assume that cooling water flow rate is greater than lube oil flow rate. So this over here is my water. And this on this side, this whole thing is my oil. So if the mass flow rate right here of the water is greater than the mass flow rate of the oil, it says, which of the following temperatures are possible? Well, what you need to do then is to make this equal sign true. Here's what you need then. The delta T's, to make that equal sign true, the delta T of the water has to be less than the delta T of the oil. That's what you know for sure, right? So water must be less than oil in terms of delta T. So now they give us a bunch of temperatures. So water delta T less than delta T of the oil. That's what we've learned. Delta T water must be less than delta T of the oil. So then they give us some possibilities. Alpha, Bravo, Charlie, and Delta. And they tell us lube oil outlet temperature. Lube oil out. Remember, lube oil in was 130. So I'm just going to put 130 right here. I know that was the inlet temperature of each one of these. And then it says cooling water out, cooling water outlet temperature. And if you'll recall, they told me in this that the inlet temperature to cooling water was 70. So I'm going to put 470s right here, right? So let's see which of the following are possible such that the delta T of the oil must be greater than the water or water less than oil. So alpha says 90 degrees lube oil outlet temperature and cooling water is 100. Then for the second one, it says 90 and 110. Charlie is 100 and 100. And delta is 100 and 110. So here we go. We see that the delta T of the water would be 30. The delta T of the oil would be 40. So is the delta T of the water less than the delta T of the oil? It sure is. So alpha's looking good. Let's check this one. This one's 40 and 40. That's equal to, not less than. So it cannot be Bravo. This one is 30 and 30. Can't be Charlie. Delta. 40 and 30. So the delta T of the water is actually greater than the delta T of the oil. And there's a lot in this bank. It's just which one's possible. There's only one that's possible, one that meets the criteria that the delta T of the water must be less than the delta T of the oil. And that's alpha. The water's at a 30 degree delta T. It's got the greater mass flow rate. Therefore, lube oil has to have the greater delta T.